Okay, guys. So today we're going to continue our discussion about the searching and sorting the arrays in general. So I remember last time we covered, the selection sort. Yeah. Did you talk about the selection sort? What do you think? Yes, no? Difficult. Okay, let's go over this one again. Okay. So what do we mean by the selection sort here? Now we have an array. Okay. Yes, whatever code you have in this class, you can use them. It's fine. It's yours. Okay. The codes that the homeworks, in the labs, the codes that you distribute in the class is yours, so you can reuse them. You are not going to reinvent things from the beginning, from scratch. Anyway, so we start looking what? We start searching for the array, for the specific item in the array. And we figure out that if the data is like unsorted, so it's hard. Yeah, it's going to be time consuming because the best time, or let's say the best performance you can perform in searching with the data that require from you to start searching from the first item up to the end of the last item of the array. This is the worst case scenarios. Okay, so we figure out that maybe if the array is sorted, maybe we can have a better way in order to perform the search in a more efficient way. That's what we're looking for here. With the computer science here, you are going to solve the problem. Even later when you try to find a job, they know that you are going to answer the question. Okay, you're going to write the code in order to do the job that you're looking for. But what they're looking for, actually, the way that how you think, the way that how can we come up with a better way in order to solve the question. That's going to be like the fastest, would you say, the most efficient or optimized code that you can come up with. Okay, so here, that's the sequential search. Start from the beginning, compare with every single item. In the worst case scenario, you're going to search the entire array, and the best case scenario, you're going to find whatever the item that you're looking for. And after that, you said, maybe we can sorting the array itself, okay? By the way, today we're going to try to use something new, okay? We try to use my iPad different way. So let me try, hopefully this works. Let me know if you can't see. Okay, so sorting array, start this array, how it looks like, something like this. I'm going to use my mouse, okay? Then I do have an items here. For example, 3, 5, let's say 2, 0, and let's say 1. Okay? Then I want to find a way in order to sort them. What we're going to do here? Remember, I'm trying to sort this one in a place. That means I'm going to sort the data using the same array. So I'm not going to sort this one using another array. So the simple thing we're going to take a look, we covered this one last time, we call selection sort. So selection sort, it depends on the way that you want to sort the data. Either it's going to be ascending order or the descending order. That means you're going to ascending order, that means you have the small value going to be in the left, and the right, or the end of the array is going to be the largest element, yeah? So here, I'm start with the selection sort to sort the data in, let's say, an ascending order. So take the first item here, or try to first search for the entire array. Try to find the largest element that you can find. What's the largest element? Whatever, and for example, in this case, it's going to be 5, yeah? Put the 5 at the end of the array. Okay, so it looks like you need to do what? If I put or store the 5 at the end of the array, I need to find out a way in order the value that used to be there must be what? Swap with the location where the highest value located. So in this case, it looks like you need to do what? 5 is going to be take the place of the 1, and 1 is going to take the place of the 5. Okay, so we have a 3, 1, 2, 0, then 5. Then the next iteration, I'm going to say what? I'm going to just reduce the size of array by 1. This means because I know this is the last element of this array, it's the place of the last element. So it's not going to be affected. It doesn't be changed during the sorting array because this is the location for the last element. So now reduce the size of the array by 1 and repeat the same operation. Every iteration, you're going to do what? Try to find the largest element of the subarray, then locate this one, put it at the end of this subarray. So here again, try to find the largest element. What's the largest element? Going to be 3. And swap this one with the last element in this subarray. So this one subarray start from 3 up to 0. So 3 is going to take the location of 0, and 0 is going to swap with the 3. So it will be 0, 1, 2, let's say 3. Yeah. Then I'm going to consider let's reduce the number of elements that you need to consider in the array by 1. So you produce a new sub-array. 3 and 5, they are on their location, so I'm not going to be involved. Yeah. So start looking for the largest element. In this case, it's going to be 2, and store 2 in the last element of the sub-array. So it's going to be in the same place. And after that, we have 0, 1. Be the same operation. Then after that, we end up. That's the way how to perform the selection sort. Okay, that's what we covered last time. That we give you the code, and I ask you. I wish if you get a chance at least to take a look to the code and see how the code works. Okay, so that's what we've done last time. This is the example. We show you how to perform the swapping and how to perform the code. Okay. So today we're gonna learn something new. How many of you play cards? Your cards like this? If you know how to play cards, then the insertion sort is going to be too easy for you. What do you mean? Anyway, so if you know how to play this one, then you didn't have a problem with the code. When you have new cards, what are you going to do with your hand? Generally speaking, people use their left hand, okay? They start do what? Sort the card in specific order, okay? So whatever you have a card here, your hand, assume this is your left hand, and those are the set of cards that you have in your hand. So if you have these cards, looks like you have, assume that at the beginning you have a 3, 5, 9. Then now we have a new card, which 4. You need to find the place for the 4. What we're going to do here, you do what? You search or compare the value 4 with all the elements that in the left side. You compare 4 with the 9. If the 4 less than 9, this means I'm going to shift the 9 in one position. And after that, compare 4 with the value of the card that I want to insert with the next element here, which is with 5. If 4 less than 5, or in other words, if 5 greater than 4, I need to push the 5 to the right position. And now compare 4 with 3. If 4, let's say 3, in this case, I need to push 3 to the right. If not, this means this is the right position for the 4, then I'm going to insert the 4 here. So it's going to be 3, 5, 4, 5, 9. Now do the same operation with 2. At the beginning, when you play cards, you start to have only one card in your hand. When you put the card in one hand, this means this card will be sorted because the array contains only one element. If you have a new card, assume that you get the second card. So what you're going to do here, you're going to compare this with every single card on the left or in your left hand in order to find the position. And you're going to repeat the same operation with every single new card. This is what it's called the insertion sort. So in one way, when you perform the insertion sort, it looks like the data is going to be sorted like this. So see your hand, something like this. You have you can divide the cards into, or the area of the data that you have into 3 parts. I'm going to talk about this one. This is the card that you want to find the position, or you want to insert, the new card that you have. Or maybe you give you a set of cards. What we're going to do here, you start have from left to right, start sort every single element or every single card in the right position. And at specific time, you're going to divide the cards in your hands to 3 parts. Here, the card that you want to insert, find the location. In the left, all the cards in the left side is sorted in the right order. All the cards in the right, or let's say the right part of your hand, all of them contains what? Unsorted cards. So you're going to sort them one at a time. Okay? So that's what we did here. So again, that's the explanation here. So start again as if for every single item, you're going to compare the yellow one is compare them in the left side to the cards your hand that are in sorted order, and 2, 8 unsorted, and 4 that's the one that I want to insert or find the place to put the result in the place. So in order, if we have an array of n elements, so for example, you have 5 cards, or in our case, for example, we have 6 cards, okay? 6 elements in this array. We wanted to sort them. So here, this is the code how it works. So it looks like we have an outer loop which is going to represent the number of cards that you want to insert or you wanted to sort them. Usually we have n-1 times. So it looks like here we have, for example, we have 6 cards. I'm going to try to sort 5 cards. Why? Because if you have only 1 card in your hand, we assume that this card is already sorted. So there's no need to sort this card. Assume that the first card that you have is 3. I want to sort the 3. It's alone by itself. So I'm not going to consider take care how can you perform this one. Okay? So if you have n cards or n elements, I'm going to perform the outer loop is going to have what? It's going to iterate n minus 1 times. For each iteration for the outer loop, I need to find the way in order to what? To find the place or best place in order to insert this card. Okay? What do you mean by to find the way? That means it looks like we need to compare with the number of elements in the left in order to find the place. So here, outer loop, as you mentioned, we have n elements. It's going to be n minus 1. Okay? The indexes start from 1 up to n minus 1. Okay, we agree with this one? So for each element, if the element value, since the outer loop is going to be represented as I, yeah? For I equal 1 to n minus 1. For every single value of I, so when I say, remember, I start with a 1, that means I need to find the place for the first element, number 5. Then I2 for the place for 9, I3 for 4, I4 for 2, the value of I is 5. That means take care of find the best place or the insert the element 8 into the position on the left side. Okay, so this using the value of I is gonna help us. Okay, remember when you talk about that your hand, the card in your hand can be divided into 3 parts here. So if the value of I is gonna point to the specific element here, so you can classify the array. Remember, all the elements gonna be stored in one array, something like this. Yeah? There's the value gonna be, and we need to find a way. How can we solve them? If the value of I is going to point to this position, this specific element that I want to insert, so we can classify the array into 3 parts. 1, I need to insert the left side. That means I from let's say from 0, let's say up to I minus 1. That contains what? The list of elements they are already sorted, or the portion or the subarray that already has all the elements that are stored in this subarray is or are sorted. The element that we need to sort them still or unsorted, because this one going to be from the element I plus 1 up to n minus 1. This is the index. Clear? This is the description. This, I mean, how can we classify the data or the separation of the data within the array? If we understand this one, that's going to help us. So that means for every value of I start, it looks like we start with the element 1 up to n minus 1. For each element, I need to find the exact position in the left side. So only compare with the left-hand side parts. So it looks like for every value of I, you need to compare between what? From 0 up to I minus 1. Yeah, that's a number. But are we going to compare from the value I minus 1 or compare first with the I0? We need to compare from the right to left. Yeah, because this is all the data are sorted. So I need to try to find the best position for this element. So I'm going to compare first for every single value of I. I need to compare from 0 up to I minus 1. Actually, from I minus 1 up to 0, because I start the comparing the element from right to left. So compare this one with I minus 1. If this one, the value that's stored in the I minus 1 is greater than the value that I want to insert, this means I need to shift the value of I minus 1. I'm going to take the value of I here. Then compare with I minus 2. If the value that's stored in the I minus 2 is greater than the value that I want to set, this means I need to shift this one to the right position. And continue this one until you reach to 0. And stop. If you reach 0, there's nothing, you're going to find out that as long as you're going down until 0, we're going to exactly find the position. So this is the technique, or this is the algorithm that we're going to use in order to help us how to, find or insert. That's why it's insert. Try to find the right position to insert the element in the right position in the correct order. So this is the outer loop. It's going to be depends on the value of I from 1 up to n minus 1. And the inner loop is going to depend on the value of I. It's going to start from I minus 1 up to 0. That's the inner loop. So we somehow, of course, we are not going to perform looping because I'm not sure how many times I need to perform this comparison. Maybe 1, maybe 2, maybe from I minus 1 up to 0. It depends. Yeah? So that's why we're going to use the inner loop as while. And the value of, while loop, okay? And the value of while starts from the, let's say, I minus 1 down up to 0, okay? So let's see the code. This is the pseudocode, how it looks like. So this is the description. That's what I've just mentioned here in the slide 17. And I'm waiting the slides comes back. Okay. Then this is the value of I. start from 1 up to the last element of the array for every single value of I want to find the right place. So what we're going to do here, I'm going to use another variable j. Okay, and the beginning j is going to be equal to the value of I. Then I need to make sure that, remember what we did here. If we go here back, we tried, for example, compare 4 with 9, and the 9 is greater than 4. What we're going to do here, we're going to shift the 9 to the right. So the 9 is going to take the override the value, whatever we have stored here in 4. So we need to make sure that at the beginning, in order to find the right place for the element, I need to copy or keep track of the value, or let's say store the value somewhere. Because if we shift the 9 to the right, the 9 is going to override the value 4. So we're going to lose this value that's stored here. Because remember, shift it to the right. So take the place, whatever the value. That's why we said at the beginning, before you do anything, you want to, let's say, find the place for the value that pointed by the value I, yeah? Element indexed by the value I. Store whatever the value here in the temp value, temporary variable, hold it somewhere. Then now, start iterate, okay? I said if the j not equal to 0, that means you didn't reach the last element. And the value of the element at the index j minus 1, at the beginning j minus 1 equal to what? The value of I minus 1. So remember the highest value in the from the sorted subarray, right? So in this case, for our example, it's going to be point to the 9 here. Yeah? Then, do what? Shift the element at the index j minus 1 to where? To the right. So that means shift it to the element j. Yeah? Then reduce, decrement the value of j minus 1. That means it looks like we are here. 9 is greater than 4. So shift 9 to the 4, and the whatever store the value that's stored in the 9, and override whatever have under this position with the value of j. Then now I need to compare the value of 4 with what? With the element j minus 2. I reduce the value of j plus minus 1. I mean decrement the value of j minus 1 in order to go with the next element. Then after that, remember the comparison is going to be from the high to the low. Okay, the position for the subarray that contains the sorted element. Then I keep doing that until I found, I mean, this is a condition, the value that pointed at the j minus 1 is not greater than 10, or the j is not equal to 0 anymore. So in this case, what I need to do here, I'm going to assign the current element, but whatever I have in the temp, put it in the location that pointed by j. Okay, let's have an example here. So at the beginning, now we have I and j, and you know how it looks like, yeah? So we have this array, okay? All the elements, we need to sort them. Remember, at the beginning, we start from 1. That means we assume that the first element is already sorted. So now, when the I equal to 1, the loop start I equal to 1, 2, 3, that are all the possible value of I need to find what here? I need to find the best position or location to store the value 26 in the left subarray. So this is the first item, is stored, sorted, sorry. Then the loop of j here is pointing to this location, j equal to 1. What you need to do here, take whatever stored in the j1 and store in the keep copy for the value 26 somewhere. Okay, that's what you did here. So save the value here, the temp value. So we have a temp 26. Then after that, we convert 26 with 17. That's what we did here. That's what you're doing here. J minus 1. Yeah? But whatever the element of j minus 1, in this case, is 17 with 26. Is 17 greater than 26? So I'm going to do what here? I'm going to exit from the while loop. Did it change anything? No. So assign the current element value stored in the temp to what? The element at the index of j. The index of j is still equal to the value of I equal to 1. So this one is going to be stored in this position. So that's what you have, 17, 26. This is the inner loop done. The value of I equal 2 now. So that means please find good place in order to insert the element that pointed by the value of I equal 2. So I need to store 5 in the subarray, in the left subarray. All the elements in the before the value from 0 up to I minus 1 are sorted. You see that 17 and 26. So far, so good. Do I speak fast? I'm trying to slow down, okay? This is who am I, okay? I try to speak slowly, but when you get excited, then I'm continuing to speak so fast. I will try to speak slower. Okay, slowly. There. So now, I mean, the value of I equal 2. The first thing you need to do what? I equal, put the I in the J. So j equals the value of I equal 2. Okay. Then check whether the value of j not equal 0. No, 2 is not equal 0. And also the value that element at the index j minus 1, which in our case 26, okay, is greater than the value of 10, which in this case 5. Yes. This means, okay, shift whatever j minus 1 to the right. They're going to override the value of and decrement the value j by 1. That's what we're going to do here. So the value 5. After that, the first thing I need to do here, I need to shift the value that's j minus 1 stored in that. Right? So it's going to be in the j. So we override the value of 5. Don't worry, we have like a temp value variable that holds the value of 5. Then now, the j minus 1. Now the j is going to be point here. So it looks like the j is going to keep tracking the position that this is the best place so far that you all might be going to use in order to store the element. If you get out from the loop, while loop, so you are going to use this, the most updated value for the j in order to store the element in this position. So compare 26 with what? I mean 5 with 20, I mean the value of j, sorry, the j here. So I need to compare what the while loop with the j minus 1. Yeah? First, the j is not equal to 0, it's equal to 1. And the j minus 1, in this case in our array, is going to be the value of j1, sorry. J minus 1, it will be, I mean, 17. Yeah? 17 with the 5 is greater than 5. Yes. So shift the 17 to the right. Then after that, up decrement the value of j minus 1. So now the value of j equal to what? That's what we have so far. Yeah. Now the value of j equal to 0. I'm going to exit from the loop, yeah, and do what here? Increment the value of I. If you still have an element, sorry, I need to base the value of j. I want to insert the element in this position because I have to find the place in order to store 25. You got this, guys? In this case, if the j equals 0, so that means I'm going to exit the loop. No more variable need to compare with. Yeah? And that means you reach the lower level, so you have to store the element in this position. Okay, so here we have 5. You have to, you know, after today's class, take a paper and pencil and try to go over the code again by hand. Give every single element. Try to trace down the code. Tracing down the code is going to make sure that you understand the structure, how it looks. I don't want for me to memorize. Just take this one. Oh, this how insert. Then this is the code that I want to do. No, you need to understand to make sure it works. And you understand how the structure or the mechanism behind this code that we use. The algorithm. Question. Okay. Good. So now we have the j, the I value of I equal what? The value of I equal. What's the current value of I now? Is 3. Perfect. So I need to find the place in order to store 12. The same. What's 12 in the 10 variable plus a j equal value of I. Now j equal 3 is the place that you want to insert. And after that, compare with the j minus 1. Enter the while loop. So it looks like find in order to check the 12, find any place until you reach the 5 on the right position. Compare with 26. The j minus 1 with whatever I have here right now in the 10. 26 greater than 12. Yes. Shift the 26 to the right and do what? Decrement the value of j by 1. So j is going to be pointed to this position. Good. Now what else? Continue the loop. Still the value of j not equal to 0. So compare whatever we have a j minus 1. So j is here. So it's going to be 17 with 5. Is 17 greater than 5? Yes. Shift 17 to the right. Decrement the value of j by 1. So it's going to be 17. Shift to the right. Then after that, I'll just move the pointer. Remember, I'm just copy. I'm not going to move the element. I'm just shifting. So take a copy, whatever you have here, store it here. That's why you have 17, 17 twice in this case. Or 26, 26 twice. Okay? Then now j minus 1 is 5. Is 5 greater than whatever you have in the 10? No. This means exit the while loop and you store whatever the element that you have at 10 in the position that pointed by the value of j. So the 12 is going to be stored here in this position. and it's what I have. So done the loop, and we have, the end of the loop. So this is the code. It's easy if you understand how the code works. So it's easy just to want from you to now plug. Let's say the official definition, for example, when you say that j minus whatever the element pointed by the j minus 1 and the element pointed by j, and such. So we need to find a way how to perform that. Write this one the right way. So this one sorted Java and insertion sorted client. So the code is available in the Blackboard. So let me just, open the Eclipse and try to, just run this one. Okay, see how it works. Meanwhile, we have two classes. Class we call this one sorter, and the second one we call this one insertion sort client. Maybe you're gonna build. It's good idea to have one class you call this one sorter, and put all the different algorithms that allow you in order to perform sort. Different types sorting algorithms. So you have one class, so you can use even the exam. If you want to use it, it's fine. It's your class because you build it. That contains multiple number of different types of sorting algorithms. The only thing you need to do is create an object of this class or whatever the sorting algorithm that you want to use. So we check 8. This is the insertion sort. I call this one insertion sort. This is the sorter. Okay, the class, the method that we have here. The only thing I did is just type the code, see how the code looks like. We do have an array. Remember that this is the selection sorting. Sorry. What I did here, the sorter array, class, I collect all the types of sorts that we covered so far. The insertion sort, the selection and the insertion. This is the insertion sort, how it looks like. I have one method, return value, if you wanted to do. If not, since you work with array, you don't have any return value, by the way. Then we have a j10, but we have the value of I. It traces over every single element from 1. You have to start from 1 up to the last element of the array. If you want to ask you a question, why you need to start with 1? Because you assume that the first element is already sorted, and it's going to be a waste of time. You see that right now, we can, for example, iterate over every single possible element here, but it's going to be a waste of time. Going to affect your overall performance when you write your code, because you're going to perform condition or iterate over a specific element that you are not, that for 100% is not going to be getting changed. Okay. The same thing we did it with selection sort. What we did here, we try to reduce the size of the element by 1 every time we try to find the place. After we find the right place for the last element. You can include this one in the competition, but it's going to be wasting of time in this case. So actually not in this case, because for the selection sort, you need to reduce the size. Otherwise, you're going to have the last element going to be always the last element. So you keep repeating yourself forever. Anyway, so this is the while loop. That's the way how to perform that. Nothing there fancy. Only thing it will show you is the insertion sort client. Create an object, generate, let's say, 6 random number from 1 up to 5,000, and you try to sort them using this technique. If you run your code, and hopefully, this is the element before you perform the insertion sort, and this is, the element after you insert or finish the insertion sort. Okay. So what's the benefit of sorting data? You're going to see that if you are computer science, you're going to study, next semester, I guess, data structure and algorithms. You're going to see that you have a different type of techniques of sorting. Actually, we cover some of them later when you talk about the recursion. We're going to show you a better way in order to perform another ways in order to perform or search, let's say, sorting the element. And you see that if the data is sorted, the rest of the task that you try to perform is going to be much easier. Okay. For example, searching for a specific element, try to produce the data in a specific order, etc. Since the data is sorted, then the next task with other tasks that you're going to perform, the data will be more efficient. Can be performed more efficient. I'll try to find my slides. You can see it, but you can feel it. Anyway, what if you have an object? For example, you have student object or student class and create many objects. And this object contains what? Many instance variable, yeah? Then we wanted to sort them. So in this case, generally speaking, you have to specify one, say, instance variable used as a sort key in order to perform the sorting, because I cannot say this object gonna be less than or greater than that object. If you have, for example, 100, say, create an array, and this array is gonna be declared or instantiate, let's say, 100 objects from the student class. So now we have like 100 objects, each of them is gonna correspond to the specific student. Then you will wanna sort them. If assume that the student class is going to contain information about the student, it might be like the student name, the student number, the ID, etc. So in this case, for example, student ID and name, and let's assume that you have a GPA or whatever. This each object going to contain the three elements here. Each object, yeah? Assume that we have 100. We want to sort that. So you can say 01 up to say 100. You can perform the same operation that we did. But remember, the previous, the algorithm that you showed to you that specifies specific element. Yeah. But here you have to tell me you are going to sort the data based on what? Is specific, to say, instance variable. Yeah. So when you work with the object here, only thing you need to tell here is, for example, if you try to say, let's say the while loop, how it looks like. When you write the while loop, you say while, for example, whatever the element j less than or equal to 0, y not equal to 0, and at the same time you say object, whatever the value of object, dot, let's say, you can say object 1, dot, let's say, give me, let's say, I'm going to sort this one based on the ID, and the value of ID. Now you can compare this one with, they say, the value of the second ID, or the other object of ID. So in other words, if you have an object of data, you need to specify what the element of the instance variable that you wanted to perform, or you want to check or sort the data based on that specific order. So you can specify the order based on the ID or the name or the GPA. Okay. So how can now we assume the data is sorted? Can you use search the data after the data is sorted? Yes. Do you think that's going to be more efficient, this operation of the searching? Yes. Okay. So we're going to take a look at the sequential search of a sorted array. You are going to start with the beginning and to the end of the array, of course. This is the way that sequential start iterates over every single possible element. You start from the beginning up to the end. But since the data is sorted, we're going to have like advantage, we can use them. Okay. So when the array is sorted, okay, you can implement a more efficient algorithm that we try to do here in order to perform the sequential search. At the beginning of the last lecture, we cover, the sequential search using over unsorted data. So here, if the search key is not in the array, so we can detect the condition, when you find what here. Let me have an example here. So assume the element that you have, I'm going to sort the data here, okay? But the element would be 1, 5, 10, 15. And the search key that you're looking for, whatever, give me any number. Let's say 5. Let's say I'm looking for 7, okay? This is the key that I want to looking for. This is the value that I want to search. So start in the beginning here, okay? And you can compare this one with the element, if the elements exist or not. You can say, for example, if the value, assume the array is x, and say x. If the value of x is say I, say less than, for example, the key that I'm looking for, less than or equal, let's say this will be the key looking for. This means you still need to continue and find the search here. So start here. If the value here is less than or equal the key that I'm looking for, yes. I will compare this one with the next time I ask you why this is the case. If the value of this key, or the value of x, is less than or equal to the key, that means there's a chance, still we have a chance, hopefully, that you're going to find the element if it exists. Because until this point, I cannot tell that you have to stop. Okay, I compare now, increase the value to the next, advance to the next element in the array x. If the value of x2, in this case 10, is what? Is less than or equal the value of key, continue. If we reach this point, and define the key that I'm searching here, let's say, is higher than the search key. So that means it looks like someone can you give you advice? Don't waste your time and continue, because 100% you will never find the element. because now we reach the point to the source, to the entry of this array, since the sorting in ascending order, all the element beyond this point is greater than 10. Let's say, assume that continue up to 100 or something. Okay, so don't waste your time. So you see that if we don't have, the data is not sorted, we're going to perform the sequential search. That means even if you find an element greater than the element that I'm looking for, say nothing for me. I need to continue searching because the data is not sorted. But since the data is sorted, you start in the beginning. If at any moment you find out you're faced or get faced along to a specific element that is greater than the element that you're looking for, less than, if that one is greater than the key that you're looking for, this means stop, don't waste your time. You never find the element that you're looking for. Do you have a question here? Yes, exactly. You see that? So for example, I'm looking for, let's say, 5, or let's say 15. You start with here. As long as, or you can iterate whatever the conditions that you can perform. If this element, as long as this element is less than or equal the element that you're looking for, continue to the next element. Is this one less than or equal to the element that you're looking for? Yes. For example, assume that you're looking for 15. Is 10 less than or equal? Yes. Is 15 less than or equal? Oh, yeah, it's equal. And I'm gonna, of course, in the condition that we have, I need to make sure with equal, then display the location. But again, just for the last time, okay? I promise, I repeat this one. If you came across an element in the array, and this element is not less than, is greater than the search key that you're looking for, don't waste your time and continue. Definitely you're gonna waste your time, because if you continue, you're gonna just search. So using the sorting the data, of course, we're gonna be, cost for the sorting algorithm. Of course, we have more efficient algorithm, we're gonna perform the sorting, okay? But since the data sorting is going to help us a lot, it's going to reduce the time that we're going to spend in order to produce or perform whatever task we're going to perform over the sorted data. So that's what we have here using sequential search. Let's show you the code here. So assume that we have whatever an array here, and you have in your key you're looking for a specific element. You start to say if the value starts from the 0 up to last element, that we try to perform here. But in this case, we have something different here. We're going to say as long as the element that in current position is not greater than the element that you, or the key that you're looking for, or the search key that you're looking for, you can continue. So that's what we did. The value x, for example, dot length. Of course, you are not going to exceed the last element of the array. And at the same time, we add this one. We add this one in order to have more, advantage of knowing that the data is sorted. Okay, so it tells about every single element. And of course, within loop, you need to make sure that with the element that you look for exact equal to the value or not. Because remember, for the 15, maybe it's going to be less than or equal 15, yes? And you make sure if it's equal, turn this one. And continue the loop until you find the element. Here you notice that we have two different returns. We have return -1 and return 1 here, I. Return I, it's okay if you have more than one return in the method. But you need to make sure that only one of them is going to be executed at any given time. Which in this case, if you find the element equal to the key that you're looking for, you are going to return to the position of the element. Okay? If not, to continue and figure out, maybe there's a situation that you never find the element that you're looking for. So in this case, I'm going to return -1. Remember, when you talk about the sequential search, we said we're going to return the index of the element if the element exists, or -1 if not. Question? Okay. So now we have a different thing. We call this one binary search. Binary search, like the data is sorted, okay? And we have a better way in order to perform the search. We are not going to perform sequential search, okay? We are going to perform what's called the binary search. Later, when we talk about recursion, etc., we're going to, I'm going to cover, talk about a little bit about what is called, the runtime complexity. How can we tell, for example, with this one's better than the other one? Which this algorithm is going to be better, or let's say a way in order to judge or to tell whether the algorithm is efficient or not. Okay, We're going to cover this one later. Anyway, so the binary search, remember, if you play a game and you know the number between, let's say have a game, you said, guess a number between 1 and 100. I have a number. Can you guess the number you have in my mind? The simple idea to do that, jump to the middle. Let's say 50. Then I can tell you is less than or greater than. So if you just said less than, that means now you are going to focus between 1 up to 50. I'm going to say 25. I'm going to say greater than. So I know that I need to search between 25 and 50. So I go to jump to the middle. So every time, give the middle number in the subarray that you try to search, until either find the element that you're looking for, or you reach either equal nothing or empty. Okay. So again, we played this game. I remember a long time when it was kids. Anyway, you have from number from 1 to 100. At the beginning, you say you guess the number between 1 and 100. We start with 50. Why start with 50? I go in the middle. Why? Because it's easy way. Now I can't reduce. You can't tell me. It depends based on the your spots. I either gonna search from here up to here, or I'm gonna narrow down my search from here to here. It looks like you reduce the size of the array that you try to search, or eliminate maybe the half of the data that we have. So if the number is greater than 50, you know that you need to do what? It's like I need to adjust my search and keeps my search between 51. Let's say, actually jump here from 51 element up to 100. Find the middle, or let's say the number between, or the halfway between 51 and 100. So here, this one allow me to eliminate around. So if you keep doing that, how can I perform this one using coding? That's what you call the binary search. Okay. So the binary search that we're going to take a look right now. We'll attempt to find the search key in an array that's sorted, of course, in ascending order. You can do the descending order. The only thing you need to do is you need to change the operator that you have. Instead, for example, greater than, maybe you're going to have less than. Okay. And by the way, even this code here that you're given here, right here, the data is in ascending order. If the data is descending order, you need just to do something here with this element that we use here. The operator, the operator that we use, this than or greater than. So if you found the key, return the index of this element. If you didn't find the key, that's mean you return -1. Okay, that's good. Why you return -1? Because we are sure 100% that if someone get an index returned by -1, that means there's not valid index. So in this case, we guarantee that we check this one. If equal -1, then the number we didn't find the element here. Okay, so how it works again. We need to compare, beginning comparing the middle element. So it looks like we have an array. So maybe we can, let's say, show you here, we're going to use 2 pointers, okay, or 2 index. One is going to say the start at the beginning, or I, J, whatever you wanted to use. And another variable is going to point to the last, or has to keep tracking, to the last element of this array, or the index, the index position. For example, we start from 0 up to what? The beginning will be start at the 0, and the end it will be number of elements array -1. So those are the index that we have, the valid index. The value of the start and the end, we are going to adjust them depends on the value that you got from the user and depends on the comparison with the middle of the array. So when start equals 0 and the array end is equal the number of elements array -1, so in this case I'm going to consider the entire array. Okay. Then you need to find the middle. How can your middle element? Take the start plus end, which is from 0. Assume the array has, let's say, 8 elements. So it will be from 0 up to 7. Divided by 2, 3.5. This is the value of integer, then it's going to be the position is going to be 3. Okay? Then, now I need to check. How can you tell the middle value of variable is going to hold, the position for the middle element of this array? So in this case, assume we have 8 elements from 0 up to 7. So the middle value is going to be 3. Okay? Remember, it's integer. I don't care about the fraction part. I need to have integer value. We don't have an index 3.5. We can't use. Okay? That's why we didn't care that we are not going to perform that using double or casting to the double. If the value in the middle, for example, equal to key, that means perfect. Return the element. Else, if you remember, you know that if you have return, that means done. This method is executed, then this is the return value. Stop executing the whole method. else if. What if? It depends now. It's not equal to the middle. The value that's stored in the middle not equal match, the element that I'm looking for, or the key, that search key that we have. Now I need to decide, either go jump to the right element or continue searching in the left half of the array. I need to divide the array into parts, tell which. If the key, or the search key, the data that's stored in the element at the middle is greater than the key, what does that mean here? Whatever comes after, let's say, middle plus one up to array, let's say at end, okay, all the element that's stored there is greater than the search key that you're looking for. That means don't waste your time searching the right side. Go to the left side, or the lower half of the array. So that means, how can I do show that I'm going to go to the left? Yeah, I need to adjust the pointer that in the middle, or the end, is equal to what? To the middle minus one. So that means I need to go to the left. Else, go to the right. Let's have an example, quick example here. So assume that we're here that we have yeah, it's more efficient. Exactly. Yeah, I think log n and log n, no, log n, yeah, and log n, because log n, this is n log, this is a log n. I think, I don't recall, but I think log n is the time complexity for this one. But we're going to cover this one later for the complexity. Later at the end of the semester, I think the last week, we're going to see that how can we judge till which algorithm is going to make sense, which algorithm is going to be more efficient. So later, you need to use the more efficient one. Okay, so here, for example, the start here is going to be the first element, and then it's going to be the last element. Okay, assume the element that we have from 0 up to 7. That means we do have 8 elements. I'm going to have 8 elements. Okay, so 0 index plus 7 divided by 2. I'm using the indexes here. Divide by 2, it will be 3.5. So I'm going to be 3. So 0, 1, 2, 3, 4, 5, 6 here. Assume those, we have an element here. So the middle here is going to point here, this position. This is start, and this is the end, and this is the middle. Okay? Now we need to compare the value stored in the middle with the element that you have, a search key that you have. If they equal, done. Return the index, with this case the middle. If the array in the middle, assume the array is x. If x is of m, based on m, is greater than the search key that I'm looking for. What does that mean here? That means whatever you have from here up to here is definitely greater than the search key that you're looking for. Don't waste your time, go there. So we need to adjust to the left. So let me have different color here. So the only thing you need to adjust, the end is not going to be here. The end must be go here, m minus 1. So in this case, you're going to see the e equal what you have, the index in the middle, minus 1. Why I said minus 1? Because I convert this one, exclude it, and go to the one to the left. If the value, what else? What does that mean? It's not equal, it's not greater than. This means the value stored here is less than that what I'm looking for. This means don't waste your time, go to the left side. Whatever you're looking for, this one is going to be less than what you're looking for. Whatever you're looking for, if it exists, definitely going to be in this part of it. So in this case, I need to do what? This, the start must be jump here. So in this case, start is equal in the middle plus 1 in order to tell that start from here. And continue the same operation. Every time, go to the middle, compute the middle value on the index, and adjust your pointers. And this is the binary search. Did we show you the code here? It's simple. Yeah. And this is the binary search, okay? We have an array that has some elements, yeah? Then, for example, this is the way how to write your code in order to ask the user, for example, provide you with the value that you're looking for. Give me the search key, the value that you're looking for. The user give me the value, then I'm gonna call the binary search. The binary search here, you have 2 elements, okay? We have the search that you look, the array that you perform the search, and here the key of the search that you're looking for. Then here our code that I showed you. Good question. Can you zoom in? Give me a second. And when I post the recording, I'm going to zoom in this one. But let me try. I think I have one thing it can perform here. Definitely there's something I can use here to make it larger. It's going to ruin everything, I guess. Give me a second. I can't see anything. And the left top. Yep. It's clear. Thank you. It's clear. Okay. So this is the code that we have. Yeah, nice. Thank you. For me, it's clear. So this is our code. You see that we have the element, enter what you're looking for, the element that you have this array, the search key, and after that you call this method. We call this on the binary search. So this method is going to perform what here? You need to specify, for example, the key, the array that you're going to perform the search over, and the search key that you're looking for here. So you call the method, you jump to the method here, and the return value is going to be the return either either -1 or the index of the element if you count. So perform the iteration here. The code, normal code. We have the while, and here, yeah. By the way, when we need to stop, we need to make sure as long as the end is greater than or equal the start, then you can continue finding the middle and figure out whether before the if statement, see whether equal or greater than or less than. If the value end, or let's say the start is exceed the end, that means they are overlapping. Once they are overlapping, that means stop. Yeah, does make sense now. You're gonna repeat yourself again, so you have to stop in this case. So this is the condition that you're gonna perform the stop here. Let me run the code. Give you like example here. Example, let's see, assume I'm looking for 45, and they found this one at the index 8. If you try to run the code, you say you're looking for 100, and 100 is not found. Why? Because it's not there, and also we need whatever you retrieve or get from the binary search. I need to do what to check the index as return value. But here, then you check whether equals, as long as not equal -1, that means I found an element. Otherwise, it's equal -1, that means I'm gonna just display or say we didn't find the element that we're looking for. Okay, so that's the binary search.